All right, hey everyone. Today we are calculating equilibrium expressions. So yesterday we wrote them, and now today we're going to calculate them. Before we do that, just a little review. Remember, equilibrium, we've been using this word a lot, describes a situation in which the rate of the forward reaction equals the rate of the reverse reaction. So what does that mean? That means as you're forming products, this chemical reaction is also forming reactants. And so this is happening at a constant rate where the rate of the forward reaction, right, going this way, is equal to the rate of the reverse reaction, the reaction going this way. Okay? So the equilibrium constant, K, which is what we've been doing yesterday, right, K equals, describes the concentration of products compared to the concentration of reactants being formed. So we can see, are we forming more products or are we forming more reactants? Even though the rate is the same, you might be forming more of one or the other. So what does K tell us about a reversible reaction? That's exactly it. It'll tell us if we have more reactants or if we have more products. So how can we figure this out? So if your K is less than 1, if you get a small number, then we say equilibrium lies to the left, right? Remember, reactants are on the left side. And this means that we have a relatively large concentration of reactants. If, however, we have a large number, something greater than 1, then we say equilibrium lies to the right, meaning we're forming a relatively large number of products. Okay. We're going to continue talking about equilibrium throughout the week. So let's start plugging in some numbers and see how this works. So the examples today, they might look familiar. You've seen these same equations in yesterday's worksheet. So if you did that, you can copy and paste the equilibrium expression. If not, we're going to redo it. So K equals products, in this case NO2. So we're going to do this. We're going to write the equilibrium expression. And then now I'm going to plug in the numbers. So step 2, I want to plug in the numbers here. Step 1, step 2, plug in the numbers. So I've got 0.012 products. It's going to be squared over N2O4 0.65. So there's no addition or subtraction. We're just multiplying and dividing here. So 0.012 squared divided by 0.65, and I get 0.00022, or if I want to put it in scientific notation, 2.2 times 10 to the minus 4. You don't have to worry about the units. I don't really care about the units for this type of problem. But we end up with a really small number, right? This is definitely less than 1. So if we get a small number, what does that mean? Does equilibrium lie to the left or to the right? So if it's a small number, we see that equilibrium lies to the left. Okay, so this reaction favors the production of reactants. Okay, so that means we've got more of this chemical here compared to this chemical. That's what it says, and that's what it means. All right, let's try another example. So we're going to follow the same steps. We're going to write the equilibrium expression, and then we're going to plug in the number. So here, again, we saw this same equation yesterday. This is example number 2 from yesterday as well. So it's going to be NH3 squared over nitrogen times H2 cubed. Next, we want to plug in the numbers. So 0.75 squared here times nitrogen, which is 0.5, times hydrogen, which is 1.0 cubed. Okay, so I'm going to multiply everything on top and then divide by everything on the bottom. Again, I highly recommend using a scientific calculator or getting one if you haven't already. And we get a final answer of 1.125. Okay, so that's our final answer. And lastly, we want to ask ourselves, where does equilibrium lie? Is this a large or small number? So large is just greater than 1. This is indeed greater than 1. And so if it's greater than 1, we say equilibrium lies to the right. Okay, so EQ, equilibrium, lies to the right, which means that this reaction is forming slightly more products compared to reactants. Okay, the concentration of products is slightly greater. All right, that's how you calculate equilibrium constant K. Go ahead and try a couple of practice problems on your own. Just make sure you're double checking your math and figuring out which way equilibrium lies by looking at this table.